Hello everyone, today we will discuss some dimensional formulae of some important physical quantities. Now here the first physical quantity is force, and you know that force is defined as mass into acceleration. So mass is dimensionally represented as capital M in square bracket and acceleration is Lt to the power minus 2. So final dimensional formula of the force will be mlt to the power minus 2. Then the second physical quantity is impulse. It is defined as force into time. Force has the dimensional formula mlt to the power minus 2. Time is defined by t, so it will have the dimensional formula mlt to the power minus 1. Then work or energy will have the same dimensional formula, and it is defined as force into displacement. Force has the dimensional formula mlt to the power minus 2, and displacement is defined as length, so it will have the dimensional formula L, so it will be ml square t to the power minus 2. Then pressure is defined as force upon area. Force has the dimensional formula mlt to the power minus 2. Area is defined as by L square, so it will have the dimensional formula ml to the power minus 1 t to the power minus 2. Then strain, it is defined as change in dimension divided by original dimension. If it is change in length, then the original length will be L, so here it will have 0 dimension or it is dimensionless. Then elasticity, it is defined as stress upon strain. Stress is defined as force per unit area, so it will have the dimensional formula ml to the power minus 1 t to the power minus 2. Strain has no dimension, so it will be ml to the power minus 1 t to the power minus 2. Then the other physical property is surface tension. Surface tension is defined as force per unit length, so it will be mlt to the power minus 2 divided by L, so it becomes finally mt to the power minus 2. Then velocity gradient, it is defined as velocity divided by distance. So velocity having the dimensional formula Lt to the power minus 1 and distance having the dimensional formula L. So finally it will have the dimensional formula T to the power minus 1. Then coefficient of viscosity, it is defined as force upon area into velocity gradient. Force has the dimensional formula mlt to the power minus 2. Area has the dimensional formula L square. Velocity gradient will have the dimensional formula t to the power minus 1. So finally our dimensional formula for coefficient of viscosity is ml to the power minus 1 t to the power minus 1. Then angular acceleration, it is defined as angular velocity upon time. Angular velocity, it is angle upon time. Angle is dimensionless, so it will have the dimension t to the power minus 1 and divided by time, it has the dimension t. So finally it becomes m to the power 0 l to the power 0 t to the power minus 2. Then angular momentum, it is defined as j is equal to I omega. Here I is moment of inertia, omega is angular velocity. So moment of inertia is defined as mass into distance square. So it will have the dimensional formula ml square, and angular velocity has the dimension formula t to the power minus 1. So final formula for angular momentum is ml square t to the power minus 1. Then energy density, it is like mass density. Mass density is defined as mass per unit volume. Here energy density will be defined as energy per unit volume. So energy has the same dimension as the work, so it will be ml square t to the power minus 2. Volume has the dimension formula L cube. So when we solve it, it becomes ml to the power minus 1 t to the power minus 2. Then Planck constant, you know E is equal to h nu. So h is Planck constant, so it will be equal to energy upon frequency. Energy having the dimension formula ml square t to the power minus 2, and frequency is having the dimension formula t to the power minus 1. So it will finally have the dimension formula ml square t to the power minus 1. Then power is defined as work upon time, so it will have the dimension formula ml square t to the power minus 2, and time as t, so it becomes ml square t to the power minus 3. Then Stephen constant, you know that E is equal to sigma t to the power 4. So sigma is here defined as Stephen constant. So it will have the dimension formula like energy upon area into time into temperature to the power 4. Energy is having the dimension formula ml square t to the power minus 2. Area is defined as L square. Time is by T, and temperature, in some books it is written as K, in some books it is written as theta. So we can use here ml t to the power ml t to the power 3 theta to the power minus 4, or we can also write it as ml t cube k to the power minus 4. Then latent heat is defined as Q is equal to ml. L is here latent heat, so it will be heat energy divided by mass. Heat energy is having the dimension formula as energy ml square t to the power minus 2, and m mass is having m, so it will become L square t to the power minus 2. Then Boltzmann constant, it is defined as energy divided by temperature, so it will have the dimensional formula ml square t to the power minus 2 divided by theta, or we can write it as ml square t to the power minus 2 theta to the power minus 1, or we can also write it as ml square t to the power minus 2 k to the power minus 1. Then pressure energy, it is defined as pressure into volume, so it will have the dimension formula ml to the power minus 1 t to the power minus 2 for pressure, and for volume it will be L cube. So finally it becomes ml square t to the power minus 2. Then angle is defined as arc upon radius. It is length, it is also in length, so it will have no dimension, or it is called as dimensionless. Then moment of force, it is defined as force into distance, so it will be having the dimension formula ml t to the power minus 2 into length, so it becomes ml square t to the power minus 2. Then the trigonometric ratios like sin theta, cos theta, tan theta, all formulas are written in terms of the length. So the trigonometric ratios will be dimensionless. Now we will find the mathematical relations between the physical quantities using the dimensional analysis. Thank you.